Ferrari's very first lap with the SF-26 upgrade package may have revealed a problem, or a breakthrough, big enough to change everything before Spa. One lap. One new package. And data so unexpected that the entire direction of Ferrari's weekend could now depend on what the engineers saw. But here is the twist. The most important number was not the lap time. It was the gap between what Ferrari expected, and what the car actually delivered. If that gap is positive, Lewis Hamilton and Charles Leclerc may be heading to Spa with a weapon nobody saw coming. If it is negative, Ferrari could already be fighting a hidden weakness before the weekend even begins. And the real answer is buried inside one detail almost everyone has overlooked. Subscribe to the channel. To understand why that first lap matters, you have to forget the headline for a moment. A Formula One upgrade is not judged by how dramatic it looks. It is judged by whether the real car matches the promise created inside the factory. Before a new component reaches the track, engineers spend countless hours studying computer models, airflow patterns, temperatures, suspension movement, and predicted balance changes. On the screen, everything can look perfect. Then the car leaves the garage, and reality takes over. The surface is never perfectly smooth. The wind changes. The tires move under load. The driver attacks the brakes, turns the wheel, and applies the power in ways no simulation can reproduce completely. That first lap becomes the first honest conversation between the car and the engineers. And sometimes, the car says exactly what they hope to hear. Sometimes, it says something completely different. That is why the lap time alone does not tell the full story. Ferrari could run slowly and still collect extremely encouraging information. The car might react cleanly. The new parts might behave exactly as predicted. The balance might remain stable as the speed increases. Or Ferrari could produce a quick-looking lap while discovering that the car is difficult to understand. That difference is enormous. Imagine building a bridge using a detailed computer design. The first test is not about sending the heaviest possible truck across it. The first test is about checking whether the bridge moves exactly as expected. A small movement in the wrong direction can reveal a much larger issue. For Ferrari, the SF-26 upgrade package creates the same challenge. The team needs to know whether the new components are working together. Because in Formula One, no part acts alone. Change the airflow around the front of the car, and the rear may behave differently. Change the way the car sits over the track, and the tires may receive a different level of pressure. Improve grip in one type of corner, and the car may lose stability somewhere else. One apparent improvement can create three new questions. And this is where Ferrari's first major test begins. Was the upgrade producing usable performance? Not theoretical performance. Not one impressive number. Performance that Hamilton and Leclerc could actually trust. That distinction matters more than most people realize. A driver cannot use grip that appears without warning and disappears just as quickly. The car must communicate clearly. It must tell the driver what is happening before the limit arrives. When the front tires begin to lose grip, the steering should provide a warning. When the rear starts to move, the driver should feel it early enough to react. When the power arrives, the car should accelerate instead of forcing the driver to make another correction. A fast car that gives confusing signals can become exhausting to drive. And at Spa, that problem becomes dangerous. Spa demands commitment. The circuit asks drivers to carry speed through sections where hesitation can destroy an entire lap. It also asks the car to remain calm while the forces change quickly. One moment, the driver needs straight-line efficiency. Then comes heavy braking. Then direction changes. Then high-speed load. The car must adapt without losing its balance. Think of running down a hallway while someone repeatedly changes the floor beneath your feet. Carpet, ice, concrete, then a steep slope. You cannot move with confidence if every step feels different. That is what Ferrari must avoid. The SF-26 cannot be brilliant in one section and unpredictable in the next. It needs a wider operating window. That phrase sounds technical, but the idea is simple. A wide operating window means the car works well under many conditions. Different temperatures. Different fuel loads, different tire states, different corner speeds. A narrow window means everything has to be almost perfect. And Formula One rarely gives a team perfect conditions. This is why engineers pay close attention to patterns during the first runs. One clean corner means very little. A repeated response means much more. If the car behaves the same way every time, Ferrari can begin to trust the result. If the behavior changes from corner to corner, the team must investigate. And that investigation can become complicated very quickly. The driver may report that the front feels stronger. The data may show that the rear has become less stable. The stopwatch may suggest an improvement. The tire temperatures may suggest a future problem. All of those things can be true at the same time. That is the hidden complexity behind one first lap. From the outside, the car completes a circuit. Inside the garage, thousands of signals begin building a story. But Ferrari's engineers still need to decide which parts of that story matter most. A temperature change may be harmless. A vibration may be expected. A sudden balance shift may be caused by the track, rather than the upgrade. The challenge is separating noise from evidence. And Ferrari cannot afford to make the wrong interpretation before Spa. Because once a team believes an upgrade works, it begins building the setup around it. The ride height changes. The wing levels change. The suspension settings change. The drivers adjust their approach. Every decision starts leaning on the belief that the new package is delivering what it promised. But if that belief is wrong, Ferrari could spend valuable track time trying to solve the wrong problem. That is the danger nobody sees in the headline. The first lap does not only reveal information, it influences every decision that follows. And this creates pressure on both sides of the garage. Hamilton and Leclerc may describe the same car differently. One driver might feel more confident on corner entry. The other might notice instability when applying the power. One might prefer a sharper front end. The other might need greater security from the rear. That does not mean one driver is correct and the other is wrong. It means the car is being tested through two different styles. For Ferrari, that can be incredibly valuable. If both drivers identify the same improvement, the signal becomes stronger. If their feedback moves in opposite directions, the engineers must discover why. And that question could be more important than the first lap time. Because Ferrari is not simply trying to build a faster car. It is trying to build a car that both drivers can push toward its true limit. There is another reason this matters before Spa. A new package can change the team's entire strategic freedom. When a car is stable, engineers can choose between several setup directions. They can trade a little cornering grip for more straight-line speed. They can protect the tires. They can adapt to changing weather. But when a car is unstable, those choices disappear. The team stops searching for the fastest setup. It starts searching for the least damaging one. That is a completely different battle. And Ferrari's first lap may have provided the earliest clue about which battle awaits. A positive correlation between the factory predictions and the track data would give the team confidence. It would suggest that the development tools are pointing in the right direction. That matters beyond one race. When a team understands why an upgrade works, it can build the next improvement with greater certainty. But when the real car refuses to match the simulation, the problem becomes much deeper. The engineers are no longer questioning one component. They are questioning the method used to create it. And that can slow development at the exact moment Ferrari needs momentum. This is why the word shaken can point in two completely different directions. Engineers can be shocked by unexpectedly strong results. Or they can be disturbed by something the car was never supposed to do. The available information does not confirm which reaction occurred. There are no verified lap times. There is no published telemetry. There is no confirmed engineering statement explaining what the upgrade changed. So the honest story is not that Ferrari has already conquered Spa. The honest story is that the first lap opened a crucial investigation. And the answer cannot come from one dramatic moment. It must come from repetition. More laps. Different conditions. Setup changes. Driver feedback. Tire behavior. Only then can Ferrari separate a real breakthrough from a temporary impression. But there is one clue that matters more than every headline. If Ferrari can change the setup, send the car back out, and still see the same positive behavior, then the upgrade is not simply producing speed. It is producing understanding. And understanding is what allows a Formula One team to attack. That is the foundation Ferrari needs before Spa. Not excitement. Not speculation. Control. Because when the circuit begins exposing every weakness, the team that understands its car can respond. The team that does not understand it can only react. And Ferrari's first lap may have already shown which side of that line the SF-26 is standing on. Then Ferrari reached the point where the first positive signs could no longer be treated as simple curiosity. Because once an upgrade begins producing a pattern, the pressure changes. The engineers are no longer asking whether the car is different. They are asking whether the difference is real. And that is a much harder question. A Formula One car can behave well for one lap because the tires are fresh. The track can improve. The wind can change. The driver can find a cleaner line. Even the smallest adjustment can make one run look more encouraging than the next. That is why Ferrari needed comparison. Not excitement. Comparison. The new configuration had to be measured against a known reference. The team needed to understand what changed, where it changed, and whether the improvement could survive when the conditions moved away from perfect. That sounds simple. It is not. Imagine testing two umbrellas in changing weather. One appears stronger, but the wind drops during its test. The other appears weaker, but it faces a sudden gust. Looking only at the result would be misleading. Ferrari had the same problem. A faster section does not automatically prove the upgrade worked. A slower section does not automatically prove it failed. The engineers must remove the effect of fuel, tires, temperature, wind, and driver input before they can judge the car itself. And this is where the data becomes powerful. The stopwatch shows what happened. The sensors help explain why. Ferrari can study how quickly the car changed direction, how stable it remained under braking, how smoothly the driver returned to the throttle, how the tires reacted as the lap developed. None of those measurements has been published in the available source. There is no confirmed telemetry. There is no verified sector comparison. There is no official engineering explanation. But the process behind those measurements reveals why a first-lap surprise could create such tension inside the garage. If the upgrade delivered exactly what the simulation predicted, Ferrari would gain confidence in more than the new parts. It would gain confidence in the entire development path. That is crucial. A team does not build one upgrade in isolation. Each new component teaches the engineers something about the next one. When the factory model and the real car agree, the team can move faster. Future decisions become clearer. Development becomes more focused. But when the two disagree, doubt spreads. Was the component wrong? Was the simulation wrong? Was the setup hiding the benefit? Was the driver unable to access the performance? Or was the apparent improvement created by conditions that may never return? One disagreement can open 5 investigations. And every investigation costs time. That is the conflict Ferrari could not avoid. The team needed to believe in the upgrade, but it could not afford to trust it too quickly. This is especially important before Spa. At Spa, a car can look strong in one area and still lose the lap somewhere else. A lower wing level may improve straight-line speed, but it can reduce grip through faster corners. More downforce may help the driver carry speed, but it can create extra drag on the long sections. The ideal setup is not the one that wins every corner. It is the one that loses the least across the entire lap. Ferrari's upgrade therefore had to do more than add performance. It had to make the compromise easier. And that is where a wider operating window becomes so valuable. A stable car gives the team choices. A fragile car gives the team restrictions. When the platform is predictable, Ferrari can adjust the wing level without destroying the balance. It can adapt the ride height. It can respond to weather changes. It can prepare for qualifying without sacrificing the race. But when the car only works in one narrow range, every setup decision becomes dangerous. Fix the straight-line speed, and the corners suffer. Protect the rear tires, and the front becomes unresponsive. Add rotation in the slower sections, and the car becomes nervous at high speed. That is not development. That is damage control. And the first run may have told Ferrari whether the SF-26 was moving toward freedom or deeper into compromise. But there was another layer hidden beneath the technical questions. The drivers. Lewis Hamilton and Charles Leclerc do not experience a car as a collection of numbers. They experience it through feeling. The pressure through the steering wheel. The confidence under braking. The moment the rear begins to move. The instant the front tires stop responding. Engineers can see traces on a screen. Drivers feel the warning before the trace is complete. That relationship between feeling and data is where an upgrade either becomes useful or becomes confusing. Suppose Hamilton reports that the car feels calmer on corner entry. That sounds positive. But Ferrari still needs to know why. Did the upgrade create more stable airflow? Did the setup move the balance rearward? Did the tires reach a better temperature? Or did the driver simply approach the corner differently? The same applies to Leclerc. If he feels a stronger front end, the engineers must determine whether that improvement is permanent or whether it appeared only under one specific condition. Driver feedback is vital. It is also subjective. Two elite drivers can describe the same behavior in different language. One may focus on the initial turn. The other may focus on what happens as the car reaches the center of the corner. Ferrari's job is to translate those feelings into engineering decisions.